Okay, today we're going to take a look at sketching some cubic equations and some square root equations. We are just going to be doing rough sketches, and notice we're going to take a look at how the patterns on how they shift and how similar the two are after you get the basic shapes. Alright, in general, cubic equations that have a leading positive coefficient are similar in nature to this going through the origin unless we have to shift it. Alright, square root equations basically have what I call a starting point and goes up and to the right, and then it varies, from what your leading coefficient is, and then once you start shifting and translating around the graph, then that starting point changes. Alright, since unlike our parabolas and our absolute value equations that they have a distinct vertex, alright, I have named this for right now. Let's just call that a turning point. Later, if you go on into calculus, you're going to find out that that's a point of inflection. But for right now, let's just say it's a turning point, and that's what we're going to use to do our sketch on our cubic equation. And then same thing here with the square root equation. For a lack of a better name, we're just going to say our starting point on our square root equation, and that's what we're going to focus on with our shifting and sketching. Alright, now let's come back over here and focus on this cubic equation first. This leading coefficient A here is going to tell you whether or not you have what I call a regular cubic equation or one that is flipped. Alright, when that A coefficient is positive, then I like to say that we have a normal, for lack of a better word, a normal x to the third. It's going to start down low here. It's going to go up, go through a turning point, and then finish on up to the right. Okay, when it is negative, then I like to say that it is a flipped cubic equation. Alright, now, as long as I'm dealing with cubic equations that go through the origin like this one right here, then my flipped, I could say it actually is a reflection across that y-axis. Alright, but I want to say flipped here because as soon as I start translating this cubic equation all over the coordinate plane, I'm no longer going through the origin, so then I can't really say it's reflected across the x-axis. Alright, so I'm just going to show you the reflected version just here real quick. Alright, that's assuming we are going through the origin. So a flipped, or this one reflected across the y-axis, would start up at the top, come down through the origin, and go something like that. Alright, here again, just a really, really rough sketch. So when that leading coefficient is positive, it has a down-up in behavior. When it is a negative, it has an up-down in behavior. Alright, now, to determine whether or not this has been translated away from the origin, you're going to take a look at your h and your k here. This h and k is going to give you the coordinates of the turning point, what I want to call for right now, let's just say turning point. That would be the coordinates hk. So, this inside value of h is going to, if I don't want to pull out the actual point, then I can just translate it. This inside value is going to tell me how I am going to shift opposite, left, or right, because when I pull out that h value, it becomes the x coordinate of that turning point, and along the x-axis we shift left to right. This plus k value right here is going to tell me how I am going to shift same up or down, and that is because when I pull that k value out, it becomes the y coordinate of that turning point, and along the y-axis we go up or down, we shift up or down. Alright, so let's maybe I can even squeeze on two little examples here of a cubic equation. So let's suppose that our first one is y equals 3 parentheses x minus 2 to the third power plus 5. Alright, I'm going to do a really, really rough sketch. Notice I am not using graph paper here. I'm just got a sketch going. Alright, so for starters, I'm going to look at this exponent 3 right here. I know it's going to be a cubic equation, so I know my basic shape is going to look like one of these two. Alright, I can look at this leading coefficient of 3. I know it is positive, so it's going to be my regularly shaped x to the third graph. Okay, so now I'm going to start at the origin, and I'm going to do my translating or shifting. I'm going to do opposite of that number, left or right, right there. I am going to do the same up or down for this value right here. Okay, so starting at the origin, I see a negative 2, so I'm going to shift 2 to the right because I do opposite left or right. So 2 to the right, and this is a plus 5, so I'm going to shift up 5. 1, 2, 3, 4, 5. Alright, so I've shifted 2 to the right and up 5. That right there is the turning point. I know that I don't have to flip my x to the third or anything. It's just going to be my regular x to the third graph. It's going to have a down up in behavior type thing. So I could do a rough sketch right there, kind of indicating that it looks like that. Okay, now like I said, really, really, really rough sketch. We don't know how big these are or anything like that. I'm just trying to get the regular general shift of this going. Okay, now let's squeeze on another one here. Let's suppose I've got y equals -2 parentheses x plus 3 to the third minus 4. Okay, so again, I'm just going to do a rough sketch. I'm going to shift this and then see what it looks like from my shifting. All right, the x to the third here, all right, tells me it is a cubic equation. I'm going to look at this leading coefficient. That leading coefficient right there is going to tell me that I am going to have to do a flipped version of my x to the third. All right, now I'm not going to necessarily say it's going to be a reflection across the x-axis because this is going to be shifted away from that origin. So I am just going to literally just flip it wherever I'm at on my graph here. This inside number is going to tell me how I am going to shift that turning point opposite left or right. This -4 on the outside is going to tell me how to shift the same up or down. Okay, so I'm going to start at the origin, and I'm going to do the opposite of what I see right here. It says +3, so I'm going to shift 3 to the left. 1, 2, 3. And the -4 out here is going to tell me to shift down 4, so I went 1, 2, 3, 4. So I went to the left 3 and I went down 4. Alright, now under normal circumstances, if this was a positive coefficient, I would have my down up in behavior. Alright, however, since it is negative, I know it's going to flip. So I'm not reflecting or anything, I'm just going to consider it to be a flipped one. I'm going to have up, down in behavior, and I'm just going to do a real rough sketch here, coming down and kind of shifting like that. Okay, so like I said, really, really rough sketches here. We are not being very accurate at all. I can clearly see, like I said, later when you start looking at this in calculus, you're going to realize that this is a point of inflection. All right, you can clearly see where that would be at if you need to sketch. This would be the concave up, this would be concave down. So it's just giving us really, really rough sketches of these. All right, now the similarities between the cubic equation and the square root equation. I have a starting point, not a turning point. All right, however, the shifting left or right and up or down is going to remain the same. I can pull this hk out, and that's going to be my starting point, just like I did over here on the cubic equation. So that starting point would be represented by hk, all right, for a lack of a better term. Okay, now for right now, we're going to not do anything with the a's. I'll do that in a little next segment here, but let's deal with this. This h value is on the inside of the function, just like that h value is on the inside of the function. This is going to tell me how to shift opposite left or right. And the k value is on the outside, so it's going to tell me how to shift the same up or down. And here again, for the same reasons as it worked over here, when I pull that h value out, it becomes my x coordinate of that starting point. When I pull the k out, it becomes the y coordinate. All right, now let's just do one example of this, and we'll keep that a positive coefficient for right now. Let's do y equals say 3 square root of x minus 2 plus 4. Okay. All right, I want to do a rough sketch of this. Okay, not precise, no graph paper. I am just going to do a rough sketch. All right, I'm going to first see that square root symbol that's in my equation, and then I know that my basic graph is going to have a starting point and it's going to go up to the right. I don't know how high, I don't know how fast or anything. All right, I'm just doing a rough sketch, so I really don't need to be really precise with this. Okay, now I need to find that starting point. You could literally pull the point out and graph it and then go from there, or you could just do your translations here. That minus 2 is on the inside of the function. It's going to tell me how to shift opposite left or right. And then this plus 4 is on the outside. It's going to tell me how to shift the same up or down. Okay, so I'm going to start at my origin, and I see the -2, so I'm going to do opposite left or right, so I'm going to go to the right 2. And then a plus 4, it's going to tell me to go up 4. 1, 2, 3, 4. So I went to the right 2, up 4, and there's my starting point. Now, rough sketch, I know that the square root graph goes up and to the right, so I'm just going to go up and to the right. And because all I am doing is a rough sketch, I don't care how high it goes up, how fast, or how narrow it doesn't. I just want a rough sketch of what that looks like. Okay. Now, I didn't say anything about our leading coefficient here because the square root one gets a little funky. All right, so let's take a look at how a negative affects our square root equation. All right, over here what I've done is I've just done a basic sketch. No, it's not a graph, just a basic sketch of y equals square root of x. No extra numbers or anything, just to show you how this works. All right, square root of x starts at 0, 0 and goes up and to the right. Sketch, not a graph here again. All right, now if I can do no translating and I keep all of these graphs at 0, 0, no extra numbers, and negative underneath the square root right there is going to reflect across the y-axis. So I still have the point at 0, 0, but then the graph is going to go up and to the left. Okay, so I said reflects across the x-axis. That is true as long as it is at the origin, with that starting point at 0, 0. Okay, so let's go ahead and put reflects across x-axis. All right, or I'm sorry, y-axis. Okay, now keeping in mind, as soon as this gets translated to somewhere else in the coordinate plane, I am no longer reflecting across the y-axis. I'm just going to be reflecting left to right. Okay, now let's suppose that I had a negative out in front of just my basic equation. Again, I know it starts at 0, 0 because I'm not translating any of these three equations. What that's going to do is that's going to make the graph reflect across the x-axis. Okay, so again, let's go ahead and record that. Reflects across x-axis. And then keeping in mind, this is just when it's at the center. As soon as I translate this graph to somewhere other than the origin, it is just going to reflect top to bottom. It's not, you can't really say reflects across the x-axis. All right, so just a few little basic graphs there on how a negative affects square roots.